Now we have calculated the external reactions. It makes sense because we have 50 going down and we have 40 plus 10 going up. So it's 50. We have 30 going left and we have 30 going right. What do we need now? We need equilibrium at each point. Now we have all the external forces and all the external reactions. So now we need to understand what happens inside this figure, inside this geometry. And at this point, at point A, we have two forces, one force going up, one force going right. And we have a bar, vertical one, and we have horizontal one. Once we know these values, I think it's pretty easy to understand what's going to happen here. So let's do it. We're going to draw lines here. But now I'm going to use the right dimension. So AX will be 30. Then AY, it's 40. Okay. Good. Direction, it's what's just the other way around. I'm going to rotate this so it's going there, and this one and this one goes up. Dimensions, I have taken this dimension, this is 30, and I have taken this dimension, so this is 40. Okay. So now I can say that this is 30 and this is 40. So now I have two bars. We have a vertical one and we have a horizontal one. And we need equilibrium at this point, at point A. Okay, so I'm going to call this bar AF because it connects point A and point F. So that bar is going to be AF. And the other one, it's going to be AE. Do we have to calculate anything? Do we have to create the equations for vertical equilibrium and horizontal equilibrium? I don't think so, because what is AF? AF, the value of AF is going to be 30. And what about the direction? The direction is going to be like that. And what about AE? AE is going to be 40 because it goes down, and the direction it's going to be down. Now, is it tension or is it compression? If the arrowhead is going towards the point, that means that AF is compression. So I'm going to create here a layer compression. So AF is compression. What about AE? The arrow goes towards the point, so it's compression too. Okay, so at this point, we have a vertical force and a vertical reaction. We have a horizontal force and a horizontal reaction. We don't have anything with angles, so we don't have to use trigonometry. So it's just analyzing this point. We know that this is going to be leftwards and the value is 30, and this is going to be downwards and the value is 40. Now we can analyze point E. So at point E, okay, let's see what happens. So at point E, I have a bar like this. First, I will do the geometry here, and I have a 45-degree angle there. Okay, so we have these forces here at point E. How many unknowns? Okay, we have AE, and we know AE. We know that AE is going to be 40. Going up or down? Okay, so this is something that we have to understand. If that goes, forget about up or down, if that goes towards the point, it goes always towards the point. So we have another point here. So AE at this point will go towards the point. So this arrow, and we have to rotate it. Like this, and that will be compression. Okay, so compression means that the arrow goes towards the point. Okay, and now we have two unknowns, and this unknown is EF. So I'm going to name that bar EF, and that bar will be ED. We don't know if this is going to be tension, compression. So far, I'm going to use a black line because we don't know whether it's going to be tension, compression, or whatever. We know that the angle is 45 because it's the same angle as this one. So the angle is going to be 45. And now here we can apply these vertical and horizontal equations of equilibrium. So what is vertical? Okay, so what goes up? The AE goes up and it's 40. So in the vertical equilibrium, we have 40 going up. And what goes down? It's the vertical component of EF. What is the vertical component of EF? It's going to be EF sine 45. And that goes down. And now EF, it's going to go down. I think I can, because we don't have any other vertical component there. So EF will go down because if this goes up, something has to go down. ED is horizontal, so it doesn't have anything to do with this. So EF has to go down. So now if EF goes down, that means that it goes rightwards. So that means that ED has to go leftwards. So this arrow should be the other way around. Like this. Okay, so that's the only way this equilibrium can be achieved. If this goes up, we need something to go down, and the only thing that can go down is this one. If this goes down, it goes right, so this has to go left. That's the So horizontally, what do we have? What is it that goes left? ED. And what is it that goes right? Is the horizontal component of EF. So that would be EF, horizontal component, cosine 45. Okay. We can calculate EF out of this equation. So EF equals 40 divided by sine 45. How much is it? To go to the calculator, it's 40 divided by, and now I need a parenthesis, 45, trigonometry, sine, close parenthesis, it's 40 divided sine 45 equals 56.56. So EF equals 56.56. Now, how much is it ED? So ED equals EF. EF is 56, correct, 0.56. Well, I think I have something wrong here. Oh, okay, no. Times cosine 45. Okay, ED equals EF. EF is 56.56 cosine 45. So how much is it? 45 cosine, it's 0.7 times 56.56. This is 39.99. So that equals 39.99. So now we get EF and ED. Can we do it graphically? Yes. So we know that this is 40. Okay, this is 40, and it goes up. Now we have something that goes down 45 degrees. Goes down, and we have something that goes horizontally, and we have to close this polygon. Okay, so if we use chamfer, this one and that one, so this has to be 40. EF, this one has to be something close to 56.56, and this should be something close to 40 or 39.9. So let's use dimension. (56.57) and 39.99. And this is 42.